Let's do this quadratic equation application. We will use the vertical equation for the motion formula, vertical equation of motion. S, which is position at time t, equals -1/2 times g, that's the acceleration due to gravity, times t times squared, plus v sub o, which is the initial velocity of the object, times t, the amount of time it's traveling, plus s sub o, which is the initial position. In this problem we're given fireworks shot straight up in the air from 2 meters above the ground with initial velocity of 40 meters per second. They want us to find three things. They want us to find the model that expresses the height, s. They want us to find the times, maybe plural, when the height is 60 meters rounded to 1 decimal place, and do it again when the height is 100 meters. So let's do the first part, solution part A. Here we're given the initial position is 2 meters because they said it was 2 meters above the ground. And they also gave us the initial velocity is 40 meters per second. And of course, for the acceleration due to gravity, since we're using meters, we're using the 9.8 meters per second squared constant. And we are plugging those into the formula in the cloud, and that's giving us S equals -1/2 times 9.8 times t squared plus 40 times t plus 2. Then we just simplify it and we get our model. For this problem, this position S is equal to -4.9 t squared plus 40t plus 2. Now let's use this formula, this model that we developed, to answer part B. Now they want to know the times when the height S is 60. So S equals 60, find the times t. And here we'll use the quadratic formula because these are not nice integers, nice whole numbers. 60 is the S equals -4.9 t squared plus 40t plus 2. We'll move the 60 over by subtracting it from both sides. And now we identify A as -4.9, B is 40, and C is -48. We're going to plug it into the formula in the proper places. I always use parentheses to keep everything clean. Make sure I didn't forget my negative signs. Now I'm cleaning it up, and I get -40, plus or minus the square root of 463.2 over -9.8. And when I put these through my calculator, one with a plus sign and one with a minus sign, I end up with two answers, 1.9 second and 6.3 seconds. So those are the times when the position of the firework is 60 meters off the ground. Finally, let's do it again when the position is 100 meters. So everything is done exactly the same. I just use 100 in place of the 60. And then I simplified a -40 plus or minus -320.8 square root over -9.8. And the problem is, square root of a negative number is not real. So there's no real solutions to this question. And what that means is that the firework never reaches 100 meters. And that's the end.